3 today. This whole chapter so far we've been doing exponential functions. Today we're actually going to do finally some logs. I've been telling you that this chapter is exponents and logs. Where are the logs? They're here. They're here today. So we're going to do log functions. Log functions and their graphs. We'll do some graphs of logs today. So I've got 3 parts today, A, B, and C. Here we go. First of all, let's talk about what a log really is. Okay? And a log is going to be the inverse of an exponential function. A log is the inverse of an exponential function. So let's see how this works, okay? Let's suppose that we have y equals b to the x. Y equals b to the x. And let's graph that. Y equals b to the x. Graph it in blue. If you plug in 0 for x, you will get y is 1. This is just an exponential function. Let's assume that b is greater than 1. So let's say that it's growth, okay? And so your exponential function, as you know, looks like this. Okay, people are very comfortable with exponential because we see it in real life, population growing, stuff like that. We also have an asymptote through the line y equals 0. Asymptote at y equals 0. Okay? Now, let's go ahead and graph your basic, here, let's write that. Y equals b to the x. Now let's graph your basic log function, okay? And let's graph y equals log of x base b. Log of x base b. Now logs are not new to you. You had them last year. But basically, like I just said, logs and exponential functions are inverses of one another. Now, do you remember that to get an inverse, it's going to be the reflection over the diagonal y equals x? Do you remember that from a chapter or 2 ago? Maybe? No? Okay, so if I'm reflecting this over y equals x, inverses, everything switches, right? The x and the y switch. So see this point right here that's at 0, 1 becomes what? 1, 0. Good job. So it's right here. See this asymptote that is y equals 0? The asymptote is now x equals 0. Everything switches. Drugs are ready. What's that? Okay, and then there's a basic log graph right there. Okay? So let's talk about each one of these and write down some information. So let's compare. I've got exponential functions and I've got log functions. Okay? So exponential functions, and let's talk about these things for both of them. Let's talk about the domain, the range, asymptotes, okay? And so for exponential functions, do you remember what the domain was for exponential functions? All real numbers. Perfect. Now, since logs and exponential functions are inverses of one another, then that's going to be the range for my logs. All real numbers. What was the range for exponential functions? Y was greater than 0. So logs, it's going to be x is greater than 0. Everything's switching, x and y. That means domain and range switch too. Okay? The asymptotes. For exponential function, it's a horizontal asymptote at y equals 0. For a log function, it's a vertical asymptote at x equals 0. And then in these graphs, they're either always increasing or always decreasing. They don't change their increasing or decreasing, and that's true for both of them. Okay, Also, we did talk about this a little bit, but these graphs are both one-to-one. They're both one-to-one. In other words, they pass both the vertical line test and the horizontal line test. Okay? So if you're going to talk about an exponential function and you want to talk about the inverse, well, its inverse is also a function. They're functions both ways. They're one-to-one. All right, so let's talk about logs. We're going to focus on logs today. And the funny thing is, like when I first started teaching logs way back in 1999 or 2000, yeah, you weren't born yet. I started teaching a chapter on logs, and I didn't understand it. I didn't understand when I took it in high school, and then all of a sudden I hadn't seen it all through college, and now I have to teach it. And I'm like, what? So of course I go to the math guru, aka my dad, and I'm like, Dad, what the heck is a log? I don't even get this. Like, what is it? And this is what he said to me. I'll never forget this, and you're not going to either. He said, a log is an exponent. Oh. A log is an exponent. Did you know that? No? You just do them, right? You're just like, oh, I know how to find the log of something, but what is it? A log is an exponent, and I'll show you why, okay? It says this. If x is greater than 0 and b is greater than 0 but not 1, okay? Then we say that y is the log of x with base b. Sometimes I'll just say log base b of x because that's the way we write it. If and only if. Do you know if and only if? We abbreviate it as if and only if. Some things are just if, like it's this, if, that. That means it only goes one way. If and only if means you can go that way and this way. You can come back. So it's the log if and only if b to the y equals x. Okay? So this right here is the log form. That's the log form for the exponential function. And do you see this y right here? This log equals y. What's y over here? An exponent. A log is an exponent. Okay? Now, we're going to do some simple evaluating of logs. You're going to like these, maybe. You're going to remember how to do them, maybe. Okay? So here we go. Number 1. Evaluate. No calculator. Evaluate by hand. Okay, my calculator will do log of any base. I don't know if yours does. But mine, I have a button that has, it'll do log of any base. But I don't want to do that. I want you to do these in your head. Okay? So here we go. Let's start with simple and work our way to a little bit harder. Let's take log base 2 of 8. Now, some of you know the answer right away. Maybe you have some of them memorized. Maybe you just know how to do them. But this is how you evaluate a log. You have to think of it as in its exponential form. What you're doing is 2 to the what equals 8. See, we're trying to find the exponent. That's what a log is. What exponent gives me that? And then there's no figuring it out I got to add 2 to both sides and subtract and divide. No, you have to think of the answer, right? So 2 to the what power gives me 8. What's the answer? 3. Perfect. The log is 3. The log of 8 base 2 is 3 because it's the exponent that would go on 2. Let's try another one. How about this one? Log base 3 of rad 3. Ooh. Some of you guys are going to be super fast at this, okay? Let's wait for the other people to kind of figure it out too. So if I change this into its exponential form, 3 is the base. To what exponent gives me the square root of 3? 1/2. The square root of 3, the exponent on that is 1/2. Do you remember these from last year? Yeah? Yeah? Some of you are going to be even better than last year at these. Ooh, let's do a fraction. Log base 5 of 1 over 25. Log base 5 of 1 over 25. All right, here we go. 5 to the what gives me 1 over 25. Yes, Jeanette, you're so good. Well, I know that 5 squared is 25, but how do I get that down into a fraction? That would be a negative number of -2. Okay? Now, let's go back real quick up to here. You don't have, you can just look with me right now. Do you see this? When I said domain and range, x for the log, like if you have log base b of x equals y, x has to be a number that's greater than 0, and y is going to be any real number. Okay? So what that means is all these outputs that I'm getting, the outputs are positive, I got a fraction, I got a negative, that's great. But here, I can't put negative numbers or 0. You cannot take the log of a negative number or 0. Okay? All right, let's try another one. Let's do log base 4 of 1. Log base 4 of 1.
0.
Yes, 0. So 4 to the what equals 1, and that's 0. Okay? All right, that brings us to some basic properties. So basic. It's like the word lately. I don't know. I've seen it pop up so much. All right, basic properties. Basic properties for logs look like this. You can have the log of any base of 1. We just did that. We did log base 4 of 1, log base 10 of 1, as long as b is greater than 0. And that would be always 0, okay, no matter what. The other one, another basic property would be if you have log base b of b. What's the answer to that? What's log base 3 of 3? What's log base 5 of 5? 1. These are so basic, huh? This one, log base b of b to the y. So this is asking you b to the what equals b to the y? Y. Good. Good. And then one more that's not so basic, I don't think. But if you have b to the log base b of x, this is equal to x. So you have a base and then it's raised to a log, then the answer is going to be x. Yeah?
So for the third property again?
Yes.
So if it was like log base 3, 9, you can take out the second from the 9?
Yes.
Okay.
Yes. Do you see what she's saying? If you have log base 3 of 9, you can really write this as log base 3 of 3 squared. Like that.
Yeah.
And the answer is 2. Or you can go 3 to the what is 9, and that's 2 also.
Yeah.
So, yep. Nice. Okay. So, that was part A. Let's go to part B now. Part B. Okay, we're also going to have some logs that are kind of important. Like those were all different bases and stuff, but the bases that we're going to have common logs. And we're also going to have natural logs. Okay, these show up more than the other bases like base 3, base 5. These are certain bases that you're going to see. So let's start. We're going to do 2 of these. Let's start with common logs. So a common log has base, does anyone know? 10, yes. A common log has base 10. Okay, our number system is base 10. So that's why it's so important here. So common log is base 10. So if you have y equals just your basic log x with no base there, we automatically assume that that is base 10. Okay? This is true if and only if 10 to the y equals x. So with common log, we're going to do 2 things. We're going to evaluate by hand. We're also going to evaluate on our calculator with common logs. So let's do this one, number 2. We're going to evaluate by hand first. So here's some more logs by hand. Let's evaluate Log of 100. We'll start easy on you. Can you do these pretty quickly in your head? You're pretty good at these? Yeah? Okay, there's no work to be shown here, which you like, especially you boys out there. Yep, that's a sexist remark. Okay, so we're going to go 10 to the what equals 100? 2, good. Or in Spanish, dos, good. Or Portuguese, doge. Okay, B, here we go. How about log of the 5th root of 10? What, by hand? Are you crazy? Nah, you can do that. What's the answer? 1/5. Did you do really good on this chapter last year? You don't remember? I know Katie did. She told me. Shout out to Katie on the video. Okay, letter C. Here's a good one. Log of 1 over 1,000. How many of you guys didn't do really well on this chapter last year and you're like, oh, I hate logs? Yes, Sam, okay. You're going to be okay. You're going to like it better this year. Jeanette's like, yeah, you're going down, sorry. She's going to beat you, yeah. Okay, so we're thinking 10 to the what exponent gives me 1 over 1,000? -3, yeah. So 3 gives you 1,000. -3 brings it down into the fraction to give you -3. Good. All right, here's one of those ones that has that weird property that we just did. How about 10 to the log 6? We just learned a property. It's weird, huh? What's the answer? 6. It's 6. And we're like, what? Right? That's weird, huh? Yeah. The base is 10. Okay, now let's do some on our calculator. Number 3. Let's evaluate using our calculator. So get your calculator out, and everyone's calculator will do base 10 because that's what it's programmed at. When you see that word log on your calculator in its little box like that, that's automatically base 10. So we can compute some logs to we'll just do it to 3 decimal places. So find out what the log of 34.5 is. Okay, these are not pretty answers. There's no nice number that this is going to be. 10 to the what equals 34.5. So you go to your calculator, you go log 34.5. Okay, and it's approximately 1.538. Back in the day, they used to have to do that by hand. And then also in the back of books, there were log charts that had these decimals to 4 decimal places. It's really interesting. Like, whatever. Okay, try log of 0. Try log of 0 on your calculator. What's going to happen? Mine says error domain. Okay, you can't plug in log of 0. Log has to be of a value greater than 0. Okay? All right, I think that's good. You got that on your calculator. By the way, for those of you who do have log of different base on your calculator, where do you find that at? You can hit alpha, window, and that gives me a shortcut to some things. It gives me a shortcut to absolute value. It gives me a shortcut to summation. Remember that sigma? We're going to do that pretty soon. That's derivatives and integrals. That's calculus. But here's log base. And I can do the log of any base. So like that first one that I did, log base 2 of 8 gave me 3. My calculator can do that. The older calculators do not have that function. Okay? All right. Let's move on. Oh, they do want you to solve some of these with common logs very in a simple way. Okay? They want you to just kind of look at it. You're not really solving equations yet. So number 4. Solve. Solve these simple equations. Let's do 2 of them. Log of x equals 3. Okay? This, you don't really need to know how to solve log equations yet. You just need to think about what it's going to be. The base is what? 10? The exponent's 3, and I'm trying to get what that's going to be. Very simple equation, right? What would x have to be here in order for the log of base 10 to be? It would be 1,000. Good. Okay? So when you get to these in your homework, you're like, I don't know how to solve log equations yet. Or maybe you do, because we did do them last year. But it's just simple log equations like this one too. Log base 2 of x equals 5. okay? So I have to think that this is the base to the exponent is going to give me what x is. So what's x? 2 to the 5th, 32. 32. And if you don't know that, you can do it on your calculator. 32 to the 5th. Okay, the other special log that we have, so that's the common log. The other special log we have would be the natural log. What's the base of natural log? E. Okay? Natural log are logs that have base E. So for this, y equals ln of x. Ln of x. Natural log. I know it should be NL, but it's ln. Natural log of x if and only if e to the y equals x. Okay? So a natural log has base E. You know, no one writes it like this, but it is log base E of x. Nobody ever writes that, okay? Because this has its own thing. Natural log of x. I usually write L in a cursive so that you don't think it's a 1. So natural log of x. All right, so let's do some. Oh, one important thing is that if you were to take the natural log of E, what do you get? You get 1. Lenny. I always call him Lenny. That's Lenny, and Lenny's a little baby. And Lenny's always 1. He's so cute. Love little Lenny. Then he gets to be a 2-year-old. No, he never gets to be a 2-year-old. Okay. We're going to do some evaluations now. So what are we on, 5 or 6? 5. Number 5. Evaluate by hand. Okay, your calculator does have a natural log button. And we're going to do some by hand, and we'll do some on our calculator. But the ones by hand, you don't need, bless you, you don't need your calculator, okay? So here we go. Let's evaluate the natural log of e to the 5th power. Natural log of e to the 5th power. Now, some of you guys know how to do this a couple of ways, which we're going to get to on Tuesday. But this right here, you're saying that the base is e. It's not written there, but it's there. See? Base is e. So we're saying e to the what power gives me e to the 5th? 5. Did anyone do this by thinking of the properties that you learned last year? Remember the property that says you can take that and move it down? Yeah, we learned that last year. We're going to do that again on Tuesday. So if you did it that way, you got 5 times Lenny, which is 5 times 1, which is also 5. So that's the other way to do it. All right, try this one all by yourself. How about the natural log of the square root of e cubed? Oh, no. Wow, we jumped up there, didn't we? The natural log of the square root of e cubed. What'd you get? Anyone get it?
3 halves.
3 halves, yes. Oh, I'm sorry, did we answer too quickly? This is not a race. Yeah. It is 3 halves. You can do this. You can rewrite this if you want to. This is e to the 1/2 cubed. Okay? I might be explaining this too much. You might just say, yeah, of course it's 3 halves. But this is e to the 3 halves. And so the natural log of e to the 3 halves would be 3 halves. Good job. All right. And then you can also do these by calculator. So number 6, evaluate on your calculator, because your calculator has the natural log button. So let's just do one of them. We don't even need letter A. Let's do the natural log of 0.48. Natural log of 0.48. And we're going to round to 4 decimal places, like we do for logs, okay? 3 or 4. It depends what they ask for. All right, here we go. Natural log 0.48. There you go. It's negative 0.7340. There it is. Okay, so natural log's on your calculator. It's right there. Boom. All right, we have one last step to go. Do you need a break? You need a stretch break in the middle here? Or you want to just go? Keep going. Okay. Last part. Part C. And I have just three more problems to do. Okay? we're going to do some graphs now of log. I heard some groans. We're going to do some graphs of logs. I like to do these using transformations, okay? Use transformations. Because we know our transformations. We know that when it's inside of the function, it's left or right in the opposite direction. When it's outside, it's up or down. When there's a negative function, we know to flip over the x-axis, stuff like that, okay? These are all the same transformations we've done before. But we need to start with our parent function, right? So here's our parent function. Parent function is something that you'll probably need to memorize. Okay, so the parent function for log will go through the point 0, 1. And just remember that we're not shifting from the origin, okay? We're shifting from that point right there, 0, 1. The other part of our parent function is that our asymptote starts at x equals 0. So we might need to shift that. Okay? Shifting x equals 0 up and down doesn't do a thing to it, but shifting it left and right will. And then your graph is going to be like this. Okay? It looks like, if you tilt your head, it looks like an exponential equation. Remember, it is a reflection of an exponential function over y equals x. So if you ever don't remember what the log is, you can always start there too. All right, so let's do some. I've got 3 examples for you. Number 1. Let's graph g of x equals, oopsie woos, natural log of x plus 2. G of x equals the natural log of x plus 2. Okay, and you're probably scared now because you're like, what? Natural log? How do I graph a natural log? It still has the same shape as a regular log. They all look pretty much the same. They might be like a little bit more steep or not as steep. So let's go ahead and first start with our parent function. And our parent function is y equals the natural log of x. Y equals the natural log of x. If you wanted to, you could plug in numbers, You could do a t-chart. Don't plug in 0 for x because you're not allowed to. Okay? If you plug in 1 for x, you will get 0. If you plug in e for x, it's kind of funny. You get Lenny, which is 1. But where's e? Do you know how big e is? 2.7 something? Yeah. So you're right about here. So here's my parent function. Okay? You don't have to worry about too many points through it. There it is, right there. It's really gross. And then our asymptote is right there. Okay. Now I'm going to graph the function y equals, or g of x equals natural log of x plus 2. And I'm going to write it in red. I'm going to graph it in red. So for this one, we're going to shift 2 to the left. 2 to the left. So you want to take this point right here, not 0, 0. Okay, there's no point through 0, 0. You want to take that point at 1, 0, and you want to shift it 2 to the left. That's your new point. So this point that was in blue is being shifted to red 2 to the left. You also want to shift your asymptote, which is through x equals 0. You want to shift that 2 to the left now also. Okay? And then this point right here, you can shift that 2 to the left. And like I said, it's just going to be a sketch. I'm really looking for if you know how to shift it and the shape of it. Okay? And that would be the graph. All right, number 8. Graph. And you don't need to use graph paper if you don't have it. I do have some over there if you want to use graph paper. That's fine. Let's graph this one. F of x equals 1 plus log x. Okay, I brought this one up because this sometimes bothers people. They don't like it written like that because it's like 1 plus log x. What's that? It's the same thing as writing f of x equals the log of x and then plus 1, right? They're exactly the same. We're used to it this way. We're used to taking our parent function, which is log x, and then shifting it up 1. So let's try that. So our parent function, of course, I'll just graph it in blue again. And you don't have to graph the parent function every time. So here's your basic parent function of log x, log base x. This is a lot flatter because it's log base 10. So if you went down here to where x is 10, y would be 1. It should be like there. It's a really flat graph. Okay? Just like if you had an exponential function of 10 to the x, that would be increasing really fast. Okay, so it's really flat here. And we're going to shift this thing up 1. Oops, I forgot to graph the asymptote too. There's the asymptote. So let's shift this up 1. So here's our graph. What's that? Your drugs are right. Oh, someone else dinged? Nice. Wow. There you go. I know, I say that every time. Okay, one more. We're almost done. 31 minutes. We just hit 31. I think that's the maximum that you can pay attention, huh? Number 9. I get it. I know. When I sit through like staff meetings. Oh, I didn't mean that. Nope. I love staff meetings. Okay. It's hard to sit for a long time, isn't it? But this is so fun and interesting. You guys don't even want it to end. All right. H of x equals negative log x. So let's start with that parent function that I graphed in the last problem, which was, your basic log graph, which looks like that. By the way, the asymptote's not going to change unless you're shifting left or right, okay? So the asymptote's not going to change here because I'm not shifting left or right. I'm actually doing a negative log x. And negative log x tells me that I need to reflect over what? Anyone remember? X-axis. The x-axis. Very good. Reflect over the x-axis, okay? So here's our x-axis right here. We're going to reflect, and it's going to look like that. And the asymptote stays the same. Yay.